In this video, we are going to talk about microservices, the fundamentals of microservices, and I'm going to explain a ground-up application which is based on AWS. Whether you are new to AWS or new to microservices, or you want to refine your knowledge in microservices, this video will be insight for you. So let's start with the basics. Let's understand what are microservices. Imagine you have an application which is loosely coupled and independent, and it is responsible for doing functionality of an individual operation. Unlike to a monolithic based application where everything is bundled into one single piece and functionality are different inside that application itself. When we try to compare monolithic versus a microservice based application, the major advantage is scalability and easy deployment of an application. In terms of microservices, we get a huge deployment advantage as well as we can scale our application very easily. Each microservice can be developed, deployed and scaled independently. It becomes much more easier to deploy and manage these applications. Creating this architecture, it's sometimes much more flexible because we can make it independently. It also becomes fault isolated. That means if one service is going down, other won't be affected due to the failure of first service, which makes your application much more reliable in terms of managing it. However, managing microservices can be a challenge. Reason being, you need to communicate data between different services, you need to transfer that from one application to another and make sure your data is consistent. Managing this can be done using different services such as Kubernetes and other cloud-based platforms. Let's try to understand through an AWS-based application how we can create or manage these microservices. If you are new to AWS, don't worry. I'm going to explain each and every service, and I'm also going to explain what this product or application is going to do. So let's get started. So here we have an application which is a dashboard-based application responsible for tracking the sales data. So let's say you are a consumer and you want to track how many number of sellers or buyers are there in your application. You can track from this application. So here we have created two microservices. The first one is used for tracking, or I would say getting the information, and then the second microservice is majorly used for analytical purposes. Now the advantage of this is the first one will independently work to just fetch the data, and the second one will independently work to analyze the data, which makes it much more easier to scale and manage. Now here you can find few different services or images. These are nothing but services of AWS. So let's understand each one of them individually. Now here I have the first service, that is Cognito User Pool. This service is used for managing or getting users on your application. So let's say if you want to enroll or add any user to your application, Cognito User Pool as a service is going to help you. Then we have attached another service that is called as CloudWatch. CloudWatch is type of a metric which is responsible for managing or getting track of each service. That is nothing but you can analyze that, okay, whether your service is performing well or not. You can see CloudWatch is attached to each and every service. The reason being, I want to keep an eye on each service so that if there is any failure, I'll be able to get a notification from it. Now, the primary service, which is our entry point, that is API Gateway. So API Gateway is your front, which is responsible for getting traffic. When we create an application, we try to create APIs, and those APIs are in form of HTTP methods or HTTP requests, I would say. This becomes your front so that any user who is coming in is going to make a request, and then that request will be moved ahead to something called as a Lambda function. Now these Lambda functions are our compute powers where our application is running. In this, consider we are using Python. So I have written a Python function which is responsible for getting the data request and for buy and sell. So we have two different functions. First function is responsible for getting the buy request, and the second one is used for the sell request. Once we get this data, we try to load that data to our database. Now DynamoDB is a NoSQL based database which is responsible for storing all the information. Now I have all the information stored. What I want to do, I want to analyze it. Now the first service is only responsible for getting this information. So all the user information will be fetched from microservice 1. The second service, as I mentioned, is used for analytical purposes. Now here we need to mention or we need to move our data from one service to another. And to do that, we need a connection. Now this connection is DynamoDB streams. This is a service which is going to extract data from my DynamoDB table, that is nothing but my NoSQL table. It is going to extract it, pass that information to another Lambda function to fetch all the data which is required for doing the analysis. Once this data is being fetched, it is going to move towards another service, which is a very important service called as Kinesis Data Firehouse. It's a special service which is specifically used for extracting the data. So imagine you have millions of users, and to get this information, it will take a lot more time, right? So we can extract this information using Kinesis data stream. So I can get that huge amount of data, and then I'm going to store that data in a temporary database. Now the temporary database is S3 bucket. It is also called as data lake. Now we have stored all our data in our data lake. I can move ahead and I can start processing that data. For that, I'm going to use few services of AWS. These are nothing but Amazon Glue, Amazon Glue Catalog, and then Amazon Athena. Athena, to be specific, it is used only for querying purposes. So here I'm going to query my data. So once I have received that data, I can query it and then I can analyze based on whatever query I write. I'll be able to get, for example, what was the sales from March 31st to May 31st. Similarly, I can write those queries and I'll be able to get that information. The Amazon Glue is responsible for doing few basic transformation in the data. There is a possibility that my data is not stable. It might have a lot of different null values, so on and so forth. To remove this redundancy or to normalize my data, I am going to create a pipeline through which I can channelize my data. Once this has been done, I can visualize it. Now talking about the upper half of the microservice, that is SNS notification. So let's say you have extracted the data and you are analyzing it. Once the analysis has been done, you can use SNS notification to get a notification in your email, and you can get all the details in your mailbox, which makes much more easier to keep it safe. So that's how we are implementing a microservice based application. So herein I have an application which is divided into two parts. One is to analyze and one is to transfer or move my data. Now the actual implementation of microservice or advantage of microservices, if microservice 1 goes down, if let's say there is a problem in my Python code in my Lambda function, the microservice 2 won't be getting any affection. It will be as good as it was before. There won't be any problem in that microservice 2. I only need to fix the service 1. Because there is a lot of isolation and independency in this service, it becomes much more easier for me to manage and scale the application. Even if I have to scale my application, I'll be able to do that. Now, this entire architecture is considered to be a serverless architecture, where we are not utilizing any server. We can also implement a similar architecture using servers. If needed, we can have part 2 where we can discuss on server-based architectures in microservices. So yep, there you have it. You know how to implement a microservice. You know the advantages. You can go ahead and try practicing these architectures, understand how they work, and happy learning.